All right, so I'm going to do problem 220. So for this one, the problem statement reads, determine the design angle phi, and phi is between 0 and 90. So I'm going to find phi, and phi is greater than or equal to 0 degrees and less than or equal to 90 degrees. Between struts AB and AC, so that the 400-pound horizontal force has a component of 600 pounds, which acts up to the left in the same direction as from B towards A. Take theta to be 30 degrees. So one helpful thing to do with these problems is to write down everything that's in the given statement. So I'm going to also include a drawing so that I can remember the problem later when I'm coming back to it, and so it'll help me solve the problem now. So down here, we have C. Up here on the wall, we have B. We have these two struts. They go out to point A. So they go somewhere out here. So A. So we have AB and AC. This is point A. We have a force of 400 pounds. And then this angle here is the theta, which equals 30 degrees, and that was given in the problem statement. And then this angle here is phi, which is what we're interested in finding. And the force, the 400-pound force, is horizontal. It says that in the problem statement. Oh no, it's not horizontal. So the 400-pound horizontal force, okay, it is horizontal. It has a component of 600 pounds, which acts up to the left in the same direction as from B towards A. All right, so I'm going to go down to the solution. So let's draw what's going on with this point A. So we have A, we have a 400-pound horizontal force, and then we have a force that is 600 pounds, which acts up to the left in the same direction from B towards A. So it would be this one here. That's 600 pounds. And that's that B towards A. And so we know that this angle here is 30 degrees. That's that theta. So that would make this one to be 30 degrees. And then we also have, so, when we do the component, or break down the forces into their components, so we have from A in that same direction as the AB, and then that has to be added to another force that would get us to that resultant force, that 400 pounds. I'm going to call that a resultant force. So the force from, or that component of that 400-pound force plus, let's pick another color, so tip to tail, plus this force, I'm going to call it force AC, is going to equal that resultant force of 400 pounds that's to the left. So let's see, we don't know that angle phi, and that would be the angle, between AB and AC. So that would be this angle here. That would be phi. That's what we're looking for. We know the 400-pound force, 600-pound force. We don't know F of AC, and we don't know phi. So this one, so we basically have a triangle that we're dealing with here. This is somewhere where the law of sines and cosines is helpful for us. So if you remember, so the law of cosines, with that we could figure out what that F of AC is. Let's see, and for the law of sines, law of sines, we'll need to know the opposite, like angle and the magnitude, so the length of those triangles. So for example, we would need to know FAC and the 30 degrees, and then we know the 400 pounds, but we don't know phi. If we knew this angle right here, that would also help. So we're going to need to find that FAC. I'll erase that, that was just messy. So the FAC we can find with that law of cosines. So law of cosines, and this is what I'd said in class that you'll probably need to review, but basically it's a squared equals b squared plus c squared minus 2bc cosine of the angle in between b and c. And so we're going to use that, so we know this, the 400-pound one, the 600-pound, and we know that angle theta. So we'll use that to figure out what that A is, which is that FAC. So I'm going to rewrite it with our values. So FAC squared, I'm just going to do a square root over here. It equals B squared, so that'd be 600 pounds squared plus C squared, which is at 400 pounds squared, minus 2 times 600 times 400 times that cosine of that angle in between those two, which is 30 degrees. So now I'm going to pause it and grab my calculator, and then we'll have the answer. So I just entered it in my calculator. I encourage you to do the same. And what I ended up getting was that FAC equals 322.967 pounds. And I just carried that out to a lot of significant figures just because we're still early in the problem. And I'd like to have a more accurate result in the end. And I'm actually going to try to keep it in my calculator. But so now we have that FAC, so now we can actually use the law of sines. So I'm going to go to the next page. Let's see, I'm going to pause for a second. All right, so now we're going to use the law of sines. So let's go to the next page. I just copied and pasted some stuff over there just so you could still see it. So now we know FAC, we know this angle, we know 400 pounds, we don't know phi. Phi's what we're after, so we can use the law of sines for that. So if you remember the law of sines, you basically have A over sine of, however you want to say it, alpha equals B over sine of beta, which equals C over sine of gamma. That's just the generic version. Let's put it in for R's, and we'll only need two of them. But so we have FAC over the sine of 30 degrees, and that's going to equal that FR over the sine of phi. And phi is what we're interested in. We know FAC is at 322.967 pounds divided by sine of 30 equals, and FR is at 400 pounds divided by sine of phi. So now I'm just going to pause it and do the calculation in my calculator. Alright, so I just entered it into my calculator. I encourage you to do the same because there's some steps where you can mess that up, just some in your calculations, which you want to be careful for. But what I end up getting is that phi equals 38.26 degrees, and we'll just change that to 3 significant figures, so phi equals 38.3 degrees. And we can go back to the problem statement just to make sure, but I believe that was all we were supposed to find. We were supposed to find phi. So we're all done, and that was between the 0 and 90 like they had said. So that's it. Thanks.